Okay, so this is Dr. Mitchell again, and we're going to walk through how to do a two-way chi-square using JASP. And so I'm going to start with our data set, and I'm actually going to use a similar data set in what we used in class, where we're looking at the ankle injuries, and we're looking at different degrees of ankle injuries, first degree, second degree, third degree. So we're going to consider that a non-parametric variable, and whether those injuries are occurring on grass or turf, which obviously is a nominal variable, non-parametric. And so I have my data here in my Excel. Now, again, if you remember the format of this, there's different subjects for all of these. So you may have a subject who's first degree sprain on grass. So all my subjects are in rows. So we have quite a bit of data here. We have a good 60, 70 subjects here in our data set. Actually, a little more than that, sorry. 112 data subjects. So quite a bit here. So it has to be formatted again. Each row is going to be a subject with their sprain type and then what surface they're on, whether it was grass or turf. So notice here we are using words as our variables. We're not using 5.63 or things like this. And so JASP can do that. It can work with that. So this is my CSV file. I've saved this as a CSV file. So I'm going to go over to JASP, and we're going to open this up. Now I have already opened this up, so it's going to be in my recent files, but you can find that wherever it is on your computer. Open it up, and you're going to notice it's immediately going to open up my data. Now, if it's not the case, you can change by clicking over, say, field. You can change what type of variable it is. But generally speaking, and you can also rename it, by the way, like say field and turf. I don't want to call it grass. I want to call it something else. I can do that. But I don't need to do that. I like those terms. But if we needed to change this variable, we could. But they're both correct. They are both nominal. So now we're going to do a chi-square. So really, again, what we're doing are frequencies, just like we talked about previously. So we're going to go over to our frequencies tab, and we're going to go down to contingency tables. And then we're going to have a nice little window open up. Now, you notice on the left, it's going to ask, it has sprain type, field type, and we're just going to put one in a row and one in a column. And truthfully, it doesn't necessarily really matter how you do it. Just for the sake of doing it, I'm going to put sprain type in columns, field in rows, just because I can. There's no other good reason to. And then you'll notice on the side, what it's going to give me is that contingency table. In other words, what is the number in each cell? What's a number for grass, first degree, grass, second degree, so on and so forth. What's a number for turf, first degree, second degree. It's going to give us a total. So again, very similar to what we did in class. Just below that, then it's going to do the actual chi-square analysis, where it's giving us with our degrees of freedom, our value of our chi-square, and then a p-value. And as we've mentioned numerous times before, if we're going to use 0.05 as our p-value, then this number 0.02 is less than 0.05. So what we can say is that there is a significant relationship between the frequency of sprains on grass and turf and their type. Now, pretty simple, really, when we do contingency tables. There are a couple other things we can look at here if we so choose. For example, we can go down to statistics. We can do what's called a Kramer's V, which is very similar to an effect size, telling us how well these are correlated. And it's decent. It's all right. It's not awesome. Kramer's V 0.261. So that's a decent, a small to medium size effect size. We can also, if we want, get a little more in depth and include, and I'm going to move my picture up there, we can include a table that has the expected values. So now what I just did in our table, it just added the expected count in each cell on top of what is the actual count. So there might be value to that to know, yeah, it's obvious, here in first degree, it should have been 21.9 for grass, but it was only 21, it's expected was 21.8, the actual count was 29. So it does give us some idea of which of the actual values is pretty far off the expected values. And we can kind of see there, yeah, grass, first degree, that's really off from what we would have expected there, and that's really the most significant one. That's different. So we can do that. There are some other things here that we're really not going to use as far as percentages. If we wanted, we could put percentages there. We could reorder our data, but we're pretty good with the way this looks. So pretty straightforward as far as doing a two-way chi-square with JASP. I hope this helped, and we will see you in the next video.